Now let's find our Thevenin's and find our tau. How we do that is we remove our load, and since we have independent sources, we can we zero out our independent sources and find the equivalent resistance from A to B. So how we do that is we zero out our independent sources. If we have dependent sources, we cannot do it. We have to find the open circuit over our short circuit. But in this case, we can use a shortcut. So what we do is we zero out voltage sources by shorting them, zero out current sources by opening them. So this voltage source would short, and we want to find the voltage, or we want to see the equivalent resistance seen from A to B when we remove our load. We removed our capacitor, and what we see is our Thevenin's, our equivalent resistance is 2 ohms plus 4 ohms in parallel with this 4 ohm resistor, and that would give us 4 ohms. So what's seen, what the resistance seen from A to B is 4 ohms. So that's our Thevenin's. Now we find tau. Thevenin's is 4 times our capacitance, 0.5 farads, and we have 2 seconds as tau. Okay, and now let's plug it into this general solution for natural and step responses. But we're gonna write the solution for only the final voltage. So what it will look like is V of C. If we can rearrange this equation where we only have the final voltage XF, only in terms of XF on one side and this XT on the other side. So this VC of T equal to 0.51 minus 0.5, which you have a 1/2 volts, minus e to minus t over tau, which is 2 seconds. That's 2 tau times, we have to add u of t, and we'll come to that right now. And the reason why we do u of t is because this is a step function, but this is a step function for 1 volt only. That's why we declared this as 1 volt to replace it by 1 volt voltage source. Because the current source, we replace it by a 1 amp current source. And now what we do, since this equation is only for the final voltage when we have 1 volt. All we have to do is write a unit step equation for this graph here, and then multiply it by this value, this final voltage. Multiply this value by this, and then we add our initial voltage, negative 12 volts, and we tack on the u of t. Okay, let's write an equation for a unit step equation for this graph right here. What we have here is that V S of t, this voltage source, this time dependent voltage source, is equal to, well, it's going to be some, okay, so what happens is it goes from 0, that's when it jumps, at t equals 1, so we want u of t minus 1, and it jumps out about how much? 4 volts, so we apply volt 4 here, and then what happens? At t equals 2, it drops down back to 0, so it'll be minus 4 volts, so we go minus 4 volts times u of t minus 2. That's our equation for our unit step function. And now what we do is we multiply this value, this 4, times this final voltage for 1 volt. So this is for the time dependent voltage source. So we multiply this 4 by this equation, and then we delay it by t minus 1 by the time. We delay t by t minus 1. So we replace this t by t minus 1, replace this t by t minus 1, and we multiply this value, minus 4, times this final value. And we also delay this t by t minus 2. So we replace this t by t minus 2, replace this t by t minus 2. So let's see how it works out. So we're multiplying this value. Let's start with this value. 4 times this final voltage, 0.5, 1 minus e to the minus, what is t? Don't forget we're delaying. So delay by how much? This value, by this t minus 1 divided by this 2, and over here this u of t, and we also delay it by the amount by t of 1, delay by 1, so times u of t minus 1, and don't forget this value. Now we have to multiply this value by this final voltage here, multiply negative 4, so minus 4 times this value, 0.5. So it's going to look similar to this, but we're going to delay it by how many seconds? By 2. We're going to delay it by 2 seconds. So replace every t by t minus 2. So 0.5. And then times 1 minus e to the minus t minus 2 divided by 2. And delay, don't forget this u of t, delay that u of t by the same amount, t minus 2. Okay. Now this right here is our equation for that final voltage for this when the switch is in position B. Now we tack on our initial value, the one we got, negative 12 volts, and we also put it as a step function. We could. So we tack it at the end, so it'll be minus 12 e to the minus t over 2 times u of t. And this is our final solution for the voltage across the capacitor, which is greater than 0. It's equal to this. The reason why we put e to the minus t over 2 is because this capacitor is charging up. We need to find the initial voltage across this capacitor over time, and that's why we tack on this e to the minus t over 2 times u of t. Is anything less than 0? Anything less than 0, this would be 0. So anything less than 1, this would be 0. Anything less, so this would be 0. And this is our final equation. So thank you for watching.